For this example, we're going to find the product of some polynomials. If you take a look at this one, in front of our parentheses we have a single term. Inside the parentheses we have three terms. So we have a monomial times a trinomial. Essentially, how you eliminate parentheses and then combine your like terms is you go through and take each one of the values in your first polynomial. In this case, we just have one term, and then using the distributive property, multiply that by each one of the terms in the other polynomial. So 4x squared times another x squared would be 4x to the fourth. 4x squared times a negative 6x, just working with the numbers, 4 times negative 6 is negative 24, and x squared times x then with our variables would give us an x to the third. And then a 4x squared times 3 would be a 12x squared. After you eliminate parentheses, you should look to combine like terms if you can, but these terms are not like. We have an x to the fourth term, an x to the third term, an x squared term. No like terms, so we can't add or subtract them, and they are in standard form. Letter B, we're going to do an x minus 3 times A2 minus 5x plus x squared. So again, identifying what we have two sets of parentheses with nothing in between, so it is multiplication. Two terms here, so a binomial, three terms here, times a trinomial. So you're going to take each one of the terms inside the first set of parentheses and multiply those by each of the terms in the second set. So our first term in the parentheses here is an x. So I'm going to take that x and using the distributive property in my first step, I'm going to multiply by all three of the terms in the second set of parentheses. X times 2 is 2x. X times negative 5x is a negative 5x squared. X times x squared is x cubed. Now that we're done distributing the x in, we're going to move to the next term, and we will take this negative 3 that's here, and using the distributive property, multiply that by all three of the terms in the trinomial. Negative 3 times 2 is negative 6. Negative 3 times negative 5x is a positive 15x. And negative 3 times x squared is a minus 3x squared. Once you have eliminated your parentheses, then you should combine like terms, writing your final answer in standard form. To do that, we do need to identify the highest power of x. That happens to be an x to the third. We don't have any other x to the third terms, so I can just copy that down as our first term in our final answer. Next would come the x squareds, and I see we have a couple of x squared terms. I have a minus 5x squared there and a minus 3x squared there. If we combine those together, that would give us a minus 8 or a negative 8 of those x squareds. Our x terms are next, and we have a couple of those. Our very first term here is a 2x, and then a little later on a plus 15x. That would give us 17 x's. And then there's only one constant term, and that is the minus 6. That is our final answer. We've eliminated parentheses and then combined our like terms. For letter C, we're going to take a look at y squared minus 7y plus 5 times y squared minus y minus 3. So identifying what we have, trinomial times a trinomial, I need to take each one of the terms inside the first set of parentheses, multiply by each set of the terms in the other set of parentheses. So to start with, using our distributive property, I'm going to take this y squared and multiply by all three of the terms. Y squared times y squared gives me y to the fourth. Y squared times a negative y is a negative y cubed. And y squared times a negative 3 is a negative 3y squared. Now I'm going to take the second term and distribute that into all three terms in the second set of parentheses. So I'm going to take that negative 7y and multiply by each of those terms. Negative 7y times y squared is a negative 7y cubed. Negative 7y times a negative y would be a positive 7y squared, and negative 7y times a negative 3 is a plus 21y. All right, first term is done, second term is done. One more term left. Now I need to take this 5, and again, using the distributive property, multiply that 5 by all of the terms in that second set of parentheses. 5 times y squared is a 5y squared. 5 times negative y is a minus 5y. And then 5 times negative 3 is a negative 15. I now have all of my terms with no parentheses, and now we can combine like terms. I want this to be in standard form, so I'm going to find the highest power of x and start with that. The only y to the fourth term that we have is this first one, so I can just copy that one down. For our x cubes, we have 2 of them, these two right here, and negative 1 minus 7 is a minus 8. For our x squareds, or our y squareds rather, there are 3 of those. We have a negative 3, a plus 7, and a plus 5. So negative 3y squared plus 7y squared would be 4y squared, plus 5y squared would be 9 of those y squared terms. We have 2 y terms here and here. 21 minus 5 is 16, and only one constant term. So our final answer in standard form would look like this. For letter D, we're going to take a look at some parentheses raised to powers. So for letter D, we will do an a plus 2b raised to the third power. There's a few ways of doing this. One of them would be to simply take the a plus 2b and write it down 3 separate times. We have 3 binomials multiplied together. There are 2 multiplications happening, one here and one here. Do them separately, calculate one of them and come up with an answer, and then do the other. When I multiply these first 2 sets of parentheses together, I will end up with an a times a, which is an a squared, and a times 2b is a plus 2ab. Generally, we put our numbers first and then our variables in alphabetical order after that. 2b times a gives me a plus 2ab, and then 2b times another 2b is a 4b squared. We did not do anything with that last set of parentheses, so I can just combine, or copy that down rather. In our next step, we do want to combine these 2 like terms in the parentheses here. So we would have an a squared, 2ab's plus 2 more ab's would be 4ab's. And then the rest we copy down. So if we multiply those first 2 sets of parentheses together, we end up with this. And now we need to multiply by that a plus 2b on the end. So distributive property again, going to take the a squared, multiply by both terms. A squared times a is a cubed, and a squared times 2b is a plus 2a squared b. Next term is a 4ab. I'm going to multiply that by a plus 2b. 4ab times a would be 4a squared b. 4ab times 2b would be 8ab squared. Now finally, our last term times both terms. 4b squared times a would be a 4ab squared, and 4b squared times 2b would be an 8b cubed. If there are any like terms, we do want to combine those together, and we do have a few like terms. We have these 2 here, those are like terms. We have these 2 here, those are like terms. So final answer, we would need an a cubed to start with, and then 2a squared b plus 4 more a squared b would give us 6a squared b's. 8ab squareds plus 4ab squareds would be 12ab squareds, and then on the end are plus 8b cubed. So there's our final answer on that one. Distributive property and combined like terms. That is what we're doing on each problem. Let me do one more of those. Letter E. For letter E, we're going to take a look at an x minus 3 raised to the 4th power. That would be an x minus 3 times another x minus 3 times another x minus 3 times 1 more x minus 3. So as you go through and do this problem, there are 3 multiplications that you're going to have to do. One here, one here, one here. Multiplication is commutative. You can do them in any order that you want. If I were doing this problem, I would do this multiplication and this multiplication in my first step. If I multiply this out, x times x is x squared, and x times 3 is a minus 3x. Negative 3 times x is another minus 3x, and negative 3 times negative 3 is 9. This is the exact same thing as that, so we would get another one of those. We have some like terms here in the middle we can combine together. So x squared minus 6x plus 9 times an x squared minus 6x plus 9 is what we would end up with after multiplying those out. Now we have a trinomial times a trinomial. So distributive property again. X squared. X squared times x squared is x to the 4th. X squared times negative 6x is a negative 6x cubed. And x squared times 9 is 9x squared. Negative 6 next. Negative 6x times our x squared would be a minus 6x cubed. Negative 6x times negative 6x would be a positive 36x squared. And negative 6x times 9 would be a negative 54x. Finally, the 9. Got to multiply that in to finish this up. 9 times x squared, 9 times negative 6x, and 9 times 9. We have 9 terms across there. We do want to combine any like terms that we have. The highest power of x is our x to the 4th. X cubes would be next. There's 2 of those. Negative 6 minus 6 more would be minus 12. X squareds are next. We have 9 plus 36 plus 9 more. 9 plus 36 is 45, plus 9 more is 54. For our x's, we have negative 54 minus 54 more, and then finally the plus 81 on the end. So when you go through and you're working on these problems that involve multiplication or polynomials raised to powers, you use the distributive property to get rid of parentheses and then combine like terms, writing your final answer in standard form.